We'll start with the 45-degree triangle. Whoa, there we go. If you draw a right-angled triangle where one of the angles is 45 degrees, what can you tell me about that triangle?
That the other angle is 45.
Good. So we would know the other angle is 45. Besides being a right triangle, why is this triangle special?
It's an isosceles triangle.
It's an isosceles triangle because both angles are the same. Now, if both angles are the same, what else is the same in an isosceles triangle? The two sides are going to be the same. Now, we can put any numbers here we want. We could put 1 and 1. If we really wanted to make mental math difficult, we could put 1,234, 1,234. We're not going to do that.
Good morning.
Hello?
We've been interrupting Mr. Jonathan Ross. At the bell, could Haley Collier just come down to the office for a brief message?
Sure.
Thank you so much.
So we're going to we can pick anything we want. We're going to choose 1 and 1 because they have to be the same. A squared plus B squared equals C squared. It's going to be the square root of 2. Job. Because 1 squared plus 1 squared is 2 equals C squared. Square root both sides, you'll get C is the square root of 2. We can now, with this special triangle, because we didn't need our calculators to build that triangle, did we? No. Can you tell me what tan of 45 is without your calculator? 1. Because tan is what over what? Opposite, which is 1, over adjacent, which is 1. Quick simplification, 1 divided by 1. There we go. And we get tan of 45 equals 1. Try it on your calculator. Is that what your calculator says? You can also now do sine of 45 degrees. Sine is what over what? 1 over square root of 2. We learned in our rational unit we can't have a square root on the bottom, so we're going to have to rationalize. What would I multiply top and bottom by? Root 2 and root 2, which simplifies to root 2 over 2. Type root 2 over 2 into your calculator. Sure you can. You get decimal 707, da 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 da. Type sine of 45 into your calculator.
7.0.
That's right. They're the same. So now you can figure out sine of 45 is root 2 over 2 without your calculator. And can you see that cos is going to be identical? Cos of 45 is root 2 over 2 as well. Yes? Well, we're not doing 90 till next year, but it's not because you're just doubling the answer. You're not allowed to just double something inside and double something outside. That's not math. You double 2 sine 45s would be doubling this, but sine of 90 isn't going to just be doubling it because you're doubling inside of a function. Okay, there's our 45-degree triangle. Our second special triangle. Our 30-degree triangle and 60-degree triangle get made at the same time. You'll probably see why. If I make a right-angled triangle and I make one of the angles 30 degrees, what does the other angle have to be? 60. This is a right triangle. Is it a special triangle in any other way? What do you call this kind of triangle? Does anyone remember what a triangle with 3 different sides is called? Not equilateral, that is true, but it had a special name.
Non-isosceles.
Think of fish. What do fish have on their skin? Scalene triangle. Not a gill triangle. Good. We have a special word, scalene, for a triangle that's not special in any way. This triangle that you know nothing about, it's not very helpful. And so if it's a special triangle, right now it's not very special. However, if we take this triangle that we have and replicate it, flip it over and draw it again. We'll do it in blue. Something special happens. Oh. The whole thing becomes, it becomes 60, 60, 60, 60, 60, yeah, there we go. That makes an equilateral triangle. All sides are the same. Since all sides are the same, we can pick any number we want. Again, I would not go to 1,234 because the mental math gets a little crazy.
May I recommend -0?
We're not going to use -0. We're going to go with 2. I like Austin's thinking here. 2 here, 2 here. Why is 2 nice for the bottom? Because this half and half would make that 1 and 1. I want you to do a squared plus b squared equals c squared and write how high, or what is the height of this triangle. Careful, you know the hypotenuse is 2. Yes. So make sure you can check on your own that you get √3 for that. Because you would have 1 squared plus b squared equals 2 squared. Solve for b, and you should be able to get the square root of 3. Now, what's neat about this, let's do 30 degrees first. What is sine of 30 degrees? Sine of 30 degrees, SOHCAHTOA? Opposite over hypotenuse will be 0.5 or 1 over 2. Can you see that if I use 30, my opposite side is 1 in my green triangle? And my hypotenuse in my green triangle is 2. So I'd get 1 over 2. What is cos of 30 degrees? No. Here's my 30 degrees in my green triangle. The adjacent side is √3. My hypotenuse is 2. And tan of 30 degrees would be 1 over √3. You would have to rationalize by multiplying the top and bottom by √3. And you'd get tan of 30 is √3 over 3. I'm going to give you a head start, and you are going to figure out what sine of 60 degrees is, cos of 60 degrees, and tan of 60 degrees. Ready? No, not yet? Okay. Did you get √3 over 2 for sine 60? 1/2 for cos 60? And square root of 3 over 1, which you can write just as square root of 3, for tan of 60. Okay, look at 60. Sine is opposite. Opposite side is √3 over hypotenuse, which is 2. So I get √3 over 2. Cos, adjacent, which is 1, over hypotenuse, which is 2. Tan, opposite, which is √3, over adjacent, which is 1. So these ones you have to be able to do without your calculator, and you'll have to know how to you'll either have to memorize them or memorize how to make the triangles so you can find them out. Because once you've got the triangle, you can find them all out. Okay? Your questions that you can do for practice, for standard angles, you can do question 3. And for these exact values, you can do questions 5 and 6. One neat thing that comes out as a result of this is that if you have any point, oh, this is not where I want it. Here we go. There. This is at the bottom of page 427. If you have any point on a line and that line is in standard position, then that point can be found using the radius, and the x-coordinate is the radius times cos of theta, and the y-coordinate is the radius times sine of theta. The reason for that is if you make a triangle where this is r and this is theta, and I want to solve for my y-coordinate, using SOHCAHTOA, I would use sine. Sine of theta, opposite over hypotenuse, and multiplying both sides by r, you get that your y-coordinate is r times sine of theta. Similarly, if you redraw this triangle with a radius r and an angle theta and you want to solve for x, then you'd use cos. So your x-coordinate is r cos theta. Yeah, just let me